This is a quick explanation on how to do the math for the Enthalpy Lab that you just did. Keep in mind that you had two separate trials that you worked on. First trial was dealing with the dissolving of NaOH. Since that was calorimetry, you have to do a Q equals mc delta T. Recall that Q value you solve for is how much energy that the water gained. You're going to have to flip the sign to show how much energy the solute lost. You also need to convert from grams of NaOH solute into moles of NaOH solute. The reason being is to solve for your delta H, your enthalpy, you take your kilojoules that calorimetry found divided by the moles of NaOH. Similar thing for trial number 2 where you're doing Q equals mc delta T. Hopefully again the masses of the entire HCl plus NaOH mixture. But then you need to find the moles of the limiting reagent. For your HCl, you know the molarity, you know the liters, that can get you moles. For the NaOH, you already know that from the previous experiment. Again, why do we need that? Is because to solve for delta H, we have to take our kilojoules per mole of limiting reagent. Last part to bring up is for both of these reactions or processes, you need to solve for the known value. For the dissolving of solid sodium hydroxide in water, it makes sodium ions and hydroxide ions. So what you need to do is go to Appendix 2 and do products, which is your Na plus and your OH minus reactants, which is your NaOH solid. That will give you your known value that you can then use in order to solve for your percent air. As for experiment number 2, you have a reaction between NaOH aqueous plus HCl aqueous. Double displacement wise, this would make sodium chloride, which is aqueous, plus H2O liquid. Once again, you are going to do products delta H from the appendix minus reactants delta H to solve for that as well. Again, that concludes the notes on the calculations that you need for the lab on enthalpy.